Good day, everyone. This is Dr. Lorna Barlongo Sitoy, your lecturer for environmental toxicology. Please bear with me in some of my slides, but I'm sure that it is somewhat complete as a reference for your exam. Please bear with me in some of my slides, but I'm sure that it is somewhat complete as your reference for your exam. Please bear with me in some of my slides, but I'm sure that it is somewhat complete as your reference for your exam. At the end of my lecture, we will be able to understand what is environmental toxicology and its concept, importance of studying environmental toxicology, what is environmental contaminant, common environmental toxins, its definition, sources and uses, cause and effect, and recommendations on how to control these toxicants. What is environmental toxicology? It is a multidisciplinary study of the effects of man-made and natural chemicals on health and the environment. This includes the study of the effect of chemicals on organisms in their natural environments and in the ecosystem to which they belong. It is also the study of the effect of chemicals on human health and environment by applying the principles of biology and chemistry. It is a scientific study of the health effects associated with exposure to toxic chemical occurring in the natural, working, and living environment. For the concept of toxicology, the traditional definition of toxicology is the science of poisons. Is our understanding on how various agents can cause harm to human and other organisms. A more descriptive definition of toxicology is the study of adverse effect of chemicals and physical agents on living organisms. Look at the figure for the relationship. Now, what is the importance of toxicology? Toxicology enables the assessment of risk originating from the exposure of humans, animals, and environment to industrial chemicals, plant protection products, biocides, medical drugs and devices, consumer goods, including foods and cosmetics. Environmental contaminants, the contamination of the air, water, or soil with potentially harmful substances can affect any person or community. Contaminants are often chemicals found in the environment in amounts higher than what would be there naturally. So we can be exposed to these contaminants from a variety of residential, commercial, and industrial sources, and these are all self-explanatory anyway. Harmful environmental contaminants occur biologically, such as mold or toxic algae blooms. Here are the environmental contaminants and its definition. If we say carcinogen, an agent which may produce cancer either by itself or in conjugation with another substance. An example for this includes formaldehyde, asbestos, radon, vinyl, chloride, and tobacco. If we say teratogen, a substance which can cause physical defect in a developing embryo, and an example for this is alcohol and cigarette smoke. Mutagen, a material that induces genetic changes in the DNA, or it is also called DNA mutations. An example includes radioactive substances, X-rays, and ultraviolet radiations. Next is neurotoxins, a substance that can cause an adverse effect on the chemistry, structure, or function of the nervous system, and an example includes lead and mercury. Lastly, we have endocrine disruptor, a chemical that may interfere with body's endocrine system and produce adverse developmental, reproductive, neurological, and immune effects in both humans and wildlife. A wide range of substances, both natural and man-made, like dioxin and dioxin-like compounds. We have arsenic, polychlorinated biphenyls, DDTs, pesticides, and plasticizers such as bisphenol A or the BPA. We will dig deeper to that chemicals as we proceed to the lecture. There are a lot of toxins in the environment actually, but here are a list of the most common based on the www.lifeworkwellnesscenter.com, which is updated August 3, 2020. So actually this is the latest. We have the polychlorinated biphenyls or the PCBs. We have the volatile organic compounds or the VOCs. We have arsenic, thalines, fluoride, and the pesticides. An example for this is a DDT, a dangerous pesticide which is banned in 1972 for its health dangers and still circulating in our environment. What are polychlorinated biphenyls or the PCBs? These are a group of man-made chemicals. They are oily liquids or solids, clear to yellow in color, no smell or taste, and are very stable mixture that are resistant to extreme temperature and pressure. PCBs belong to a broad family of man-made organic chemicals known as chlorinated hydrocarbons. PCBs were domestically manufactured from 1929 until manufacturing was banned in 1979. But later on, you will notice that it is still present in our environment and even a part of our daily life. They have a range of toxicity and vary in consistency from thin, light-colored liquid to yellow or black waxy solids. Its chemical properties include non-flammability, chemical stability, high boiling point, and electric insulating properties. Although no longer commercially produced in the United States, PCBs may be present in products and materials produced before the 1979 PCB ban. And still, we have the commercial uses of PCBs, like we can see them in the transformers and capacitors, electrical equipment, including the voltage regulators, switches, reclosers, bushings, and electromagnets. They are also present in oil used in motors and hydraulic systems, old electrical devices, and fluorescent light ballasts. In addition, they are also present in cable insulation, thermal insulation materials including fiberglass, felt, foam, and cork. It is also used in the manufacturing of adhesives and tapes, oil-based paint, caulking, plastics, carbonless copy paper, their microscopic debris, and in floor finishing also. Now, let us take a look at this contamination pathway. In the industry and other sources, it is being exposed in the environment via air, food, water, and soil. And transmission to human and animals is via inhalation, contact, and ingestion. If you notice, though everyone are exposed in a minute to large amount, the workers in the manufacturing industry are those who are at risk and have a high exposure. Therefore, prevention of too much exposure and control is a must. Let us take a look at this example. The workplace concentration of PCBs such as those in areas where PCB transformers are repaired and maintained, are higher than levels in other places, such as in air in buildings, outdoor air, including air at hazardous waste sites. Let us take note that children are exposed to PCBs in the same way as are adults. Children who live near hazardous waste sites may accidentally eat some PCBs through hand-to-mouth behavior. They could also be exposed by playing with old appliances and electrical devices and by drinking contaminated water. Children can be exposed to PCBs both prenatally and from breast milk, as these PCBs are stored in the mother's body and can release during pregnancy. It can cross the placenta and enter fetal tissues. This PCB dissolves readily in fat. They can accumulate in breast milk fat and be transferred to babies and young children. PCBs can be measured in umbilical cord, blood, and in breast milk. The general effect of PCBs to human health, we have skin condition like acne and rashes, irritation of the nose and the lungs, gastrointestinal discomfort like nausea and vomiting. These are all acute effect, of course. And we have liver, thyroid gland injuries, we have anemia, depression and fatigue, reduced immunity, behavioral alterations, impaired reproduction, associated with certain types of cancer such as cancer of the liver and biliary tract, and this is due to chronic exposure to the said chemical. After knowing the properties, sources, and health effect of PCBs, let us now proceed to the recommendations of the different agencies on how to protect public health. First, we have Food and Drug Administration set residue limits of PCBs in various food to protect from harmful health effects. FDA require limits include 0.2 part of PCBs per million parts in infant and junior foods, 0.3 ppm in eggs, 1.5 ppm in milk and other dairy products, 2 ppm in fish and shellfish, and 3 ppm in poultry and red meat. The Occupational Safety and Health Administration, or so-called the OSHA, regulates the workers not to expose by inhalation over a period of 8 hours for 5 days per week to more than 1 milligram per cubic meter of air. Another recommendation from the National Institute for Occupational Safety and Health, called the NIOSH, recommends that workers not breathe air containing 42 to 54% chlorine PCB levels higher than 1 microgram per cubic meter of air for a 10-hour workday or 40-hour work week. Finally, we have the United States Environmental Protection Agency, or the EPA, requires that companies that transport, store, or dispose of PCBs follow the rules and regulations of the Federal Hazardous Waste Management Program. EPA also limits the amount of PCBs put into publicly owned wastewater treatment plants. Volatile organic compounds. For the introduction, these are emitted as gases from certain solids or liquids. Common examples of VOCs that may be present in our daily lives are we have benzene, ethylene glycol, formaldehyde, methylene chloride, tetrachloroethylene, toluene, xylene, and 1,3-butadiene. For the sources of VOCs, We have building materials like paints, varnishes, caulks, adhesives, carpet, vinyl flooring, composite wood products, upholstery, and foam. Another source is we have home and personal care products like the air fresheners, cleaning products, cosmetics, fuel oil, and gasoline. There are also activities wherein we are exposed with VOCs, like dry cleaning, photocopiers, cooking, burn woods, and smoking. According to the American Lung Association, burned cigarette creates more than 7,000 toxic chemicals. At least 69 among these chemicals are cancerous. Among the VOCs that I had mentioned a while ago, we have benzene, formaldehyde, and toluene as a component of cigarette. And to mention some other chemicals, we have acetone, acetic acid, ammonia, arsenic, butane, cadmium, carbon monoxide, hexamine, nicotine, tar. Therefore, smoking is never been healthy to anyone. Here are the signs and symptoms associated with exposure to VOCs, including conjunctival irritation, nose and throat discomfort, headache, allergic skin reaction, dyspnea, nausea, emesis, epistaxis, fatigue, and dizziness. Most of our daily use are made up of chemicals like ethylene glycol, example antifreeze and coolant. We have xylene, an example thin epoxies and enamels. Toluene, wherein we can find it in air fresheners, nail polishes and treatment, hair dyes, and some adult intimacy products. But always remember that the ability of organic chemicals to cause health effects varies greatly from those that are highly toxic and to those with no known health effect. Another example is formaldehyde. It is used as a disinfectant and sterilant both in liquid and gaseous states. Formaldehyde is sold and used principally as a water-based solution called formalin, which is 37% formaldehyde by weight. This aqueous solution is bactericidal, tuberculocidal, fungicidal, virucidal, and sporicidal. As with other pollutants, the extent and nature of the health effect will depend on many factors including level of exposure, length of time being exposed. Here are some common acute health effects. Number 1, we have eye and respiratory tract irritation. Number 2, headache. Number 3, dizziness. And number 4, visual disorder. For the chronic health effects, there will be a damage of the liver, kidney, and CNS. Another VOC is methylene chloride. Consumer products that contain methylene chloride include paint strippers, adhesive removers, aerosol spray paints. And how can this methylene chloride affect the body? When it is converted to carbon monoxide and can cause symptoms like headache, dizziness, weakness, abdominal discomfort, vomiting, chest pain, and even confusion. Carbon monoxide poisoning occurs when carbon monoxide builds up in your bloodstream. When too much carbon monoxide is in the air, your body replaces the oxygen in your red blood cell with carbon monoxide. And this can lead to serious tissue damage or can even cause death. Next is we have perchloroethylene. It is a chemical most widely used in dry cleaning. Recent studies indicate that people breathe low levels of this chemical both in homes where dry clean goods are stored and as they wear dry clean clothing. So some of the dry cleaners recapture the chemical during the dry cleaning process so that they can use or save money. They can reuse it. And they remove more of the chemicals during the pressing and finishing process. But some dry cleaners, however, do not remove as much perchloroethylene as possible all the time. So in laboratory studies, it has been shown that it can cause cancer in animals. After knowing the different organic chemicals, let us now proceed to the steps to reduce exposure. Taking steps to minimize your exposure to chemicals is prudent. Number 1. Increase ventilation when using products that emit VOCs. Make sure you provide plenty of fresh air when using these products. Number 2. Use household products according to manufacturer's directions, so you must have to read labels precautions. Number 3. Never mix household care products unless directed on the label. Number 4. Do not store open containers to unused paints and similar materials, so you must have to buy quantities that you need soon only. Number 5. Identify and remove the sources. Keep out of reach of children and pets. Number 7. Throw away partial full containers of old or unneeded chemicals safely. Number 8, potentially hazardous products often have warning aims at reducing exposure of the user. For example, if the label says to use the product in well-ventilated area, go outdoors on an area equipped with an exhaust fan to use it, or open up windows to produce the maximum amount of outdoor air if possible. For the standards and guidelines, there is no federally enforceable standards have been set for VOCs in non-industrial settings. To learn more about VOCs, including current guidelines or recommendations set by the various organizations, I have here some list of sources wherein you can read the different standards and guidelines given. In your table of elements, there are a lot of chemicals that are present in the environment. Some of them are found in the air, water, and in soil. Now, let us focus on the most common heavy metals, and one of them is mercury. Mercury is an element and a metal that is found in air, water, and soil. It exists in three forms that have different properties, usage, and toxicity. The three forms are elemental or metallic mercury, inorganic mercury compounds, and organic mercury compounds. First, we have elemental mercury. It is liquid at room temperature. It is used in thermometers, dental amalgams, fluorescent light bulbs, some electrical switches, minings. It is released into the air when coal and other fossil fuels are burned. How people are exposed to elemental mercury? When they breathe air containing elemental mercury vapors, these vapors may be present in such workplaces such as dental offices, smelting operations, locations where mercury has been spilled or released. In the body, elemental mercury can be converted into its other form, inorganic mercury. How elemental mercury affect people's health? In very high mercury vapor concentrations, it can cause severe lung damage. But in low vapor concentration but exposed in a long period of time, it can cause neurological disturbances, memory problems, skin rashes, and kidney abnormalities. Inorganic mercury compounds are formed when mercury combines with other elements, such as sulfur or oxygen, to form another compound or salt. Inorganic mercury compounds can occur naturally in the environment. These compounds are used in some industrial processes and in making other type of chemicals. Outside the United States, inorganic mercury salts have been used in cosmetic skin creams. How people are exposed to inorganic mercury? People may be exposed if they work where inorganic mercury compounds are used. Here in this table, the common mercury exposure routes are being exposed. It is via inhalation, oral, and dermal. We have here the three forms of mercury. We have the elemental, which is high via inhalation and low in both oral and dermal. In inorganic mercury, it is medium on oral and dermal, and it is low via inhalation. But in organic mercury, it is high in oral and both low in inhalation and dermal. This inorganic mercury, when eaten in large amounts, some organic mercury compounds can be irritating and corrosive to the digestive system. If repeatedly eaten or applied to the skin over a long period of time, some inorganic mercury compounds can cause similar effect to what is seen in chronic mercury vapor exposure, like neurological disturbances, memory problems, skin rashes, and kidney abnormalities. For levels greater than or equal to 200 mcg per liter are considered significant for ionizing inorganic mercury. In this slide, it shows how inorganic mercury affects the human body. If you are exposed to this chemical, there will be a formation of free radicals, reduction of antioxidant capacity, and lipid peroxidation. These three processes can lead to apoptosis and necrosis that can lead to cell death and can cause motor deficit. Organic mercury compounds. These are formed when mercury combines with carbon. Microscopic organisms in water and soil can convert elemental and inorganic mercury into anorganic mercury compounds like dimethylmercury, methylmercury, phenyl mercuric acetate, and thimerosal. This thimerosal is a well-established antiseptic and antifungal agent. This compounds was formerly used as a preservative in paints and as a disinfectant. Now, how people are exposed to organic mercury? People may be exposed to mercury in any forms under different circumstances. However, exposure mainly occurs through consumption of fish and shellfish contaminated with methylmercury and through worker inhalation of mercury vapor during industrial process. And also, mercury enter the body directly through skin contact. How organic mercury affects people's health? Large amount of methylmercury eaten over weeks to months have caused damage to the nervous system. So if it is a nervous system, signs and symptoms like tingling sensation, numbness, and tremors may be present. An infant born to women who were poisoned with methylmercury had developmental abnormalities and cerebral palsy. Mercury should not be found in water anyway, and the limit of mercury compounds is set to be 5 mg per meter cube, or it must be lower in the air. Level greater than or equal to 50 microgram per liter are considered significant to methylmercury exposure. How do we know that we are already encountering mercury toxicity? by history and physical examination findings, correlations of the sign and symptoms. Blood is primary test to detect the presence of mercury, but the amount present will decrease by half about every 3 days as the mercury moves into organs such as the brain and kidneys. We have here electrophysiologic studies of subjects exposed to mercury with various statistical extrapolation of measures of exposure, such as duration of exposure and estimated cumulative mercury dose, tissue analysis, and peak urinary mercury level. Treatment and prevention. The best way to treat mercury poisoning is to stop your exposure to the metal. If toxicity is linked to your environment or workplace, you might need to take steps to remove yourself from the area to prevent further effects of poisoning. Long term, you may need continuing treatment to manage the effects of mercury poisoning, such as neurological effects or findings. We have here chelating agents are drugs that remove the metal from your organ and help your body dispose them. Chelation therapy. It is a treatment for heavy metal poisoning not only for mercury but also for iron, arsenic, and lead. Chelation therapy involves injecting a type of medication called the chelator or chelating agent. We have EDTA or ethylene diamine tetraacetic acid, dimercaptosacenic acid, and dimercaprol. Chelators work by binding to metals in the bloodstream. Once they're injected into the bloodstream, they circulate through the blood, binding to metals. In this way, chelators collect all the heavy metals into a compound that filtered through the kidney and released in urine.